Hello everyone, welcome to this video. Today I will introduce a highly efficient script for TNT called guoyi.run, which can complete the entire pipeline of maximum parsimony phylogenetic analysis with one command, from tree searching, generating consensus trees, calculating support values, to finally exporting SVG tree diagrams. First, download TNT from its official website and also download guoyi.run from the TNT_script repository. You may also download TNT to Figtree if needed. Before using it, place both the script and your TNT matrix file into the folder where the TNT main program is located. If you are using the GUI version, you need to access the command line through the File submenu. After entering the command line of TNT's input, run space path to guoyi.run space path to data file semicolon. If running in terminal, on Windows, use TNT space run space guoyi.run semicolon. On Linux macOS, use a comma instead of a semicolon and make sure the path contains no spaces or non-English characters. As for the data file format, the first line of AT&T matrix must start with xstraight to load the data. In the example file, the numbers 4 and 5 indicate 5 taxa and 4 characters. The first taxon must be the outgroup. If you want to customize the analysis parameters, use the format TNT space run space guoyi.run space file name space data type space weighting type space k-value space consensus space resampling space prefix. The supported data types include DNA, prot, num, or a number from 2 to 32. The default is 32. For weighting, the default is extended implied weighting, EIW. You may also choose implied weighting IW or equal weighting EW. If using EIW or IW, a k-value of 12 is recommended. This is the script default, while TNT's default is 3. For EW, set the k-value to 0, which means not applicable. Consensus types include strict consensus SCR, this is the default, additional majority rule consensus MJR, and half-strict consensus HLF are available. For resampling options, use additive values. Jackknife equals 1, bootstrap equals 2, symmetric resampling equals 4, relative Bremer support equals 0.1, Bremer support equals 0.2. The default is jackknife plus bootstrap plus symmetric resampling equals 7. Note, if you choose any Bremer-related support values, they can only be used with strict consensus and may change the topology of the trees. So, in essence, the default command can also be written as TNT space run space guoyi.run space file name space 32 space EIW space 12 space STR space 7. Of course, you can also add space prefix at the end of the command, which is useful when running multiple analyses in the same folder. After the script runs, it will generate various result files. You can always check what you run at the bottom of tnt.log file. The most important one is original.svg, which is a vector image format. You can edit it using vector editors like Inkscape or Adobe Illustrator. The file, resample.tray, contains support values and can be converted to Figtree-compatible format using TNT to Figtree, though you can also directly use the generated resample.svg. Report.log summarizes indices like CI, re, and tree length. WINC, ladder.ss, can be directly imported into winclada to examine apomorphies and homoplasties. One final and very important reminder. If you use this script, you must cite the guoyi.run paper to be published in Taxa in 2025. It is also strongly recommended to mention guoyi in your acknowledgements and properly cite TNT and acknowledge the Willi Hennig Society